What up, guys? Dr. Miller here. Chapter 4, Carbohydrates. Kind of a cool chapter. Got my handy dandy board here again. Lovely. Um, want to talk to you a little bit about carbohydrates, the importance of carbohydrates. I hope you watch this. You're watching this video before, like you're doing things in order before you view the video about high fructose corn syrup. You'll have a little, I think, better understanding, at least some basic information about what you're going to hear in that video. So, hopefully, you get your quizzes done, assignment this week, right? Reflection paper, as well as just some GI tract stuff. So. I think these next sections are very exciting and because the information is so important. We're talking about carbohydrates right now, and then next week we'll talk about lipids, fats, lipids and fats, right? Same thing, and protein. Okay, so let's talk about carbohydrates a little bit. We'll hit the high points. Please read your book. Please, 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 please. Use it when you take your quizzes. I don't know what I'm looking at right now. Is that better? Okay, anyway. I'm just staring over here into space somewhere. I'll talk to you like this. Is that all right? All right. Carbohydrates. Okay. Biochemically, or I should say chemically, they have the same written chemical code. And what I mean by they is these basic forms of carbohydrates. You can think of these as the single units of carbohydrates. Okay. These are called monosaccharides. All right. Monosaccharides, there's 3 different types of monosaccharides. Some of these you've heard of, I'm sure. We have glucose, we have fructose, and we have galactose. All right? Glucose, fructose, galactose. Fructose really doesn't taste that great. I mean, it's mildly sweet. Fructose, though, is the sweet stuff, right? That's what you find in, like, fruit. Okay? We'll see, though, that glucose, fructose, galactose are metabolized a little bit differently, okay, from one for another. So although chemically they might have the same carbons, hydrogens, right, as each other, they are not the same in terms of what happens biochemically in the body, and specifically, getting too much fish oil, sorry. Specifically, what happens with the liver, what the liver does with these guys, okay, and even hormonally, like how does insulin work with these guys? So anyway, just appreciate monosaccharides. Mono means one, and they have 3 of those guys: glucose, fructose, galactose. Now, we also have disaccharides. Disaccharides are the combining of monosaccharides. Di means 2, right? So we have maltose, sucrose, lactose. Maltose you might find like barley, right? Long chains of starches will be broken down into maltose. Maltose is 2 glucose, okay? 2 glucose. Sucrose is table sugar. Okay, is what we commonly call sugar. Sucrose is 1 glucose and 1 fructose. That's what makes it sweet, right? And then we have the last one here, lactose. So you might hear somebody's lactose intolerant, right? What that means is they can't break lactose down into its 2 pieces, which is glucose and galactose. Okay, and that causes a lot of problems because we can't digest it. It causes a lot of gut issues. In order to digest carbohydrates, we have to take these disaccharides or polysaccharides, which means a bunch, if you want to think of it that way. So we might have a whole bunch of glucoses lined up, right? We could have 10 glucose attached and lined up in a starchy type food. So that's what sometimes we talk about complex carbohydrates. That's what we're referring to as polysaccharides. Okay, because they're longer chain, there's longer monosaccharides involved with them. It takes longer to break them down, which is good. Okay, because we're not going to rush the body essentially when this carbohydrates are going through the small intestine, and so we won't get as big of insulin responses. And we'll talk about the glycemic index a little bit later. But bottom line is we'd like to see a little bit more polysaccharides. Disaccharides are okay, but we want to limit the amount of monosaccharides we consume directly. Everything gets broken down into a monosaccharide. Okay, you could have a starch that has, again, 50 glucose molecules, and they have to all get broken down into maltose and then into the monosaccharide glucose, right? But if we consume straight glucose, like we do sometimes, or sucrose right away, table sugar, that's already in a disaccharide form. It's really easy to break that guy apart, and all of a sudden we have a ton of glucose and fructose, okay, which causes things like big insulin responses. Or if we have enough fructose, we make fat. So overconsumption of carbohydrates is can turn into fat production. In the 90s, you guys are too young to remember this, but when I was alive. When I was alive, a long time ago, I'm dead now. Okay, in the 90s, when I was in high school, we had the big no fat craze. So nothing had fat in it. No fat, no fat, no fat, no fat. Snack Wells was really popular. The problem is we had a ton of carbohydrates in these foods, and so people would eat the whole box of cookies thinking I am good. But the reality is that the carbohydrates carries a high calorie yield, and they're turned by the liver. They're turned into, especially fructose, turned into fat. Okay, so we have the same problem. So eating that bag of gummy bears, you might think, oh, there's no fat in these gummy bears. There's a ton of sugar in there, sucrose, and that's easily too much energy. And the liver will say, okay, you got too much energy, I'll just make fat out of it. That's how we store lots of energy, right? So we need to be careful with our consumption of carbohydrates. Now, people have gone overboard with this, right? And no carbs, carbs are evil. No. It's not carbs are evil. It's the kind of carbs where we get in trouble, the quality of carbs. If we're eating polysaccharides that have a longer time in our gut, we're going to have kind of a slower release, and so we don't overwhelm our body with simple sugar. We're not going to have a big insulin response. We're going to have energy longer. We're not going to have this big, I feel really, really good, and then I don't feel so good, right? We see that in kids. We see that in ourselves when we have a sugar rush. Okay, you drink a Mountain Dew, you're really happy for a bit, and then you're not so happy. Okay, you crash. Okay, it's because we have these simple sugars that are quickly broken down and overwhelm the body. Again, we have that feeling of feeling good, and then we drop. But the polysaccharides will be longer lasting fuel for us and not have such a big response. And we'll talk about what is actually responding in a little bit here. Okay, so mono, one, di, two, poly, many saccharides. This is our complex carbohydrates. Sometimes we call these the simple sugars. Okay. How do we break these guys down like lactose? Remember, lactose was a galactose and a glucose, right? Notice these all had glucose in them. Glucose is a common theme. What the heck is up with glucose, by the way? Well, glucose is the favored food of our central nervous system, aka the brain. Okay, so that's why glucose is so important for our survival, is the brain loves it. Now we can run off something else called ketones. Okay, you can get into ketosis. So if you're low on carbohydrates for an extended period of time, you can get into a situation where you start to use fat, okay, as a fuel source primarily, and then if that's not good enough, we will start to use protein, aka we'll go into our skeletal muscles and tear down our skeletal muscles, turn them into amino acids, and we can turn amino acids then into carbohydrates, aka glucose. Okay, you don't want to be in ketosis. That used to be a really popular thing. Atkins really pushes ketosis. The brain can run off of ketone bodies, but it's not the favored food. Okay, so again, I go back to don't fall into this like carbs are evil thing. Now, 65% carbs, like it's sometimes recommended, might be a bit high for your average person. That might be better for like an endurance athlete. 45% might be better for somebody trying to lose weight. I'm talking about percentage of your calories allocated for carbohydrates. But carbohydrates are a good thing. Okay, don't shy away from them. All right. Notice that recommendations for calories from sugars per day, like this stuff, the simple stuff, is no more than 500 calories. Okay, that's still a lot of calories per day. But you know what? We exceed that. You drink 2 Cokes, you're at 500 calories. In fact, just a little bit more than that. If you drink a typical 20 liter or 20 liter, yeah, drink 20 liters of Coke, see what happens. 20 milliliter soda. Okay. So we have a problem with over-consuming these simple sugars. Again, that causes the biggest problem. Not these complex carbs that you find in like starchy vegetables, okay, whole grain bread, things like that. It's an issue with these simple carbs. Okay. All right. I don't know if you can see this over here where it says associated with enzymes in the gut. When we break down these guys, maltose, sucrose, lactose, and polysaccharides into their smaller pieces, we use enzymes. Remember from my last talk, enzymes are kind of these little structures, proteins that bring together a substance, maybe like maltose, and then uses water to break these guys apart, these guys being the 2 glucose molecules that form maltose. Okay, so we call that breaking apart using water hydrolysis. Okay, now if we're bringing things together, we call that condensation using water. All right, if you remember basic chemistry, you know, 8th grade chemistry, right? Like an oxygen has 2 available donators or acceptors in its outer valence shell, right? And all that stuff. Remember, shells, hydrogen ions, right, have 1, so on and so forth. So, you know, H2O, water, basically what we're doing, we're filling and emptying electron shells based on whether we're hydrolyzing, cutting apart, or condensating, or bringing things together. All right. So that's how we do things. We use water to split, though, like sucrose. We split it from fructose and glucose. We use water, we hydrolyze it to do that. Okay. What is this other group here, or this other thing in carbohydrates? Hello. Okay. I wrote it in big letters because usually big letters infer like that's important, right? Fiber. Okay. Fiber. Fiber, 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 fiber. What's the big deal about fiber? Well, there's two types to start with. Soluble and insoluble fiber. Okay, insoluble fiber is typically like your whole grains. Cellulose is insoluble, like plants, right? Soluble fiber could be found in something like fruit. So fruit is basically fructose and fiber mixed together, right? So we have something like fructose, maybe not that great, but we have something fantastic like fiber that helps us do a lot of things. If it's soluble, it can be absorbed. That's the name soluble. It's fat. It can be absorbed in the bloodstream, right? It's insoluble. It's going out the gut. Now, fiber that's insoluble is going to help things like GI health and binding things, maybe like cholesterol, to send out the GI tract. Okay, we're going to essentially help ourselves be regular, right? If anybody's having overconsumption of fiber, you have to go to the bathroom. Okay, insoluble fiber. Soluble fiber is linked to things like reducing the likelihood of reducing cardiovascular disease, again by lowering cholesterol. Okay, helping to regulate blood glucose levels. All right, so fiber has a huge role in health. Great study on different types of diet and weight loss. The number one factor for weight loss in promoting weight loss was the amount of fiber in the diet. The more fiber, the more weight loss, because there's a feeling of satiety as well. So we're not breaking, especially the insoluble stuff, we're not breaking that down, so we have a feeling of being full. So we don't eat as much. Okay, we're also going to the bathroom a lot. Okay. Fiber is very important. You'll notice on their food labels, they'll have a section of carbohydrates, right? And it says sugar, right? And if there's any fiber in it, or maybe there isn't, sometimes it does or doesn't have fiber, it'll say fiber. So it'll tell you how many grams of sugar and then tell you how many grams of fiber as well, because fiber falls in this carbohydrate banner, all right? Obviously, we'd like to see a food with more fiber than we'd like to see in simple sugars. Like your Coke's not going to have any fiber in it, okay? So fiber is a good thing. Big time linkage to cardiovascular disease, right, and regulating cholesterol, bad negative cholesterol levels. Okay, heart healthy, and when it comes to weight loss, very, very effective in helping us lose weight. All right, the daily recommendations for fiber are around 25 to 35 grams of fiber per day. Okay, 25 to 35 grams of fiber today. Again, a great source of that is fruit. I always joke that apple juice or apples, if it's real apple juice, not Minute Maid, but real apple juice. Real apples, I mean, that's nature's laxative, man. I mean, if you eat a lot of fruit, you will be regular. And that's even soluble fiber. That's not even inside. Now, the cellulose in that as well, but it's heavily into the soluble fiber side of things. So that's a healthy meal, right? Those are healthy things to eat. Nutrient dense, like we talked about before, and energy less dense. Okay? Okay, let's look at a little bit at glucose function. I mentioned glucose is the favorite of the brain. Brain loves glucose. Stored glucose is called glycogen, and the main sites we store glycogen are the liver and our skeletal muscles. Those are the biggest sites for glycogen. You're like, well, who cares? That's fantastic, Dr. Miller. Thanks, Dr. Science. Okay. Well, this is the deal. We're talking about nutrition, and one of the biggest problems in our country right now in terms of health, and you can see the bottom here, is type 2 diabetes. Okay. Type 2 diabetes, people who are diabetics or pre-diabetic or heading toward diabetes. So let's talk about type 2 diabetes just for a little bit, and it'll help us understand how carbohydrates are regulated in the body, specifically glucose. Okay. First of all, there's two types of diabetes. There's type 2. Type 1 used to be called juvenile diabetes, and what we're dealing with diabetes is the regulation of blood glucose. Like when you eat that candy bar or you drink that soda, that glucose rushes into your bloodstream. Okay. Too high levels are bad, and so our body works like a thermostat. All right, so what it's going to do is say there's too much glucose, so I'm going to release this thing called insulin, a hormone, right, from the pancreas that's going to go out and take that extra glucose in your bloodstream and store it in the liver or skeletal muscles, okay, primarily skeletal muscles in this case. All right, if I'm thinking now if your liver is overloaded, right, but it will store it in the liver as well, okay. All right, a type 1 diabetic does not make insulin, so that's why a type 1 diabetic will have to inject insulin. It's because they don't make it. So if you don't have that insulin, there's no way besides exercise to get sugar into, or glucose I should say, into the skeletal muscles in the liver. Okay, that's why a type 1 diabetic has to be very careful with exercise. If they inject insulin and they go and exercise, that's a double whammy, and they can pull too much glucose out of their body and become hypoglycemic, and that can kill you. Because remember, who loves glucose? The brain, right? If the brain's not fed, you'll die acutely, especially. There's no time to make ketone bodies, not within a sufficient amount of time. Type 2 diabetes, though. Type 2 diabetes is really a disease of disuse and poor diet. So type 1 diabetics, unfortunately, they're born without the ability to make insulin. Type 2 diabetics, though, the scourge that we're seeing in type 2 is a combination of two things. One, no exercise. So if you recall, there's two ways to get glucose out of the bloodstream. One is insulin, and two is exercise. Exercise acts like insulin. So that's why a diabetic needs to exercise. Everybody needs to exercise, is to get blood glucose levels under control. Two, though, is how we eat. We're talking about nutrition class here, right? So if we overeat sucrose, remember sucrose carries a glucose in it and a fructose. It overwhelms the body. If we have something that's 45 grams of sugar, sucrose in it, okay, that's a lot of sugar to just pound into our body, into a soda, especially if it's in a fluid, all right? And so that glucose is going to go into our bloodstream very quickly, have a big insulin response. It's going to be stored primarily, the fructose is going to be stored as fat, okay? Over time, the amount of fat in the cell can increase to the point, we think this is one of the mechanisms, that we have so much fat in the cell it interferes with the receptor of insulin. Every hormone has a receptor. And if the receptor doesn't work, you can make as much insulin as you want. It's not going to be able to pull glucose into the cell. And so what we have is type 2 diabetes is not usually an issue of insulin production. It's an issue of the receptor for insulin not working. Okay, so that receptor's been basically damaged and doesn't work and not expressed properly because, or maybe even regulation's been down, but it's not working essentially. And because of that, we can't get glucose in the cells. Okay, and so we have high glucose levels, and high glucose levels can lead to all kinds of apathies, like retinopathy, right, where we have eye issues, or issues where people that need to have amputation occur down the lower extremities, right down their toes and their feet. Okay, because glucose in high levels is an irritant. It's also hard on the kidneys. All right, we have to clear glucose. Okay, so type 2 diabetes is a disease of disuse, and primarily it's a disease of poor diet, and that combination of those two things are terrible. Obesity, obviously, lots of fat in cells. There's different types of body fat as well. If we store it in our visceral fat or around our gut, that really is an indicator for type 2 diabetes, unfortunately, because that fat doesn't listen to insulin very well at all anyway. Okay, and so we have a lot of problems with regulating the sensitivity of the receptor. All right, so type 2 diabetes is a disease that, 50 years ago really wasn't talked about. But the quality of our food has diminished, and the quality of our movement has diminished. And those two things has caused type 2 diabetes to become on the rise. All right, so that's something as your generation is going to have to deal with, unfortunately. And the best way to deal with it is not metformin, is not taking all these sulfonylureas and everything else that we take, drug classes to try to fix this. The best thing to do is change the lifestyle and start eating less of these monosaccharides and disaccharides primarily, and start eating more polysaccharides, and in some people's cases maybe even less carbohydrates, period. Okay, all right. Some of the things I had on here, I'll make sure I cover. Lactose intolerance, right? You hear a lot of people are lactose intolerant. Well, lactose intolerance, one of the obviously dairies where a lot of lactose is. We tend to be more sensitive. Our ability to break down lactose is higher when we're younger, and as we get older, we tend to be the enzyme lactase tends to be expressed less and less, and so we have a harder time breaking down lactose as we get older, which is a negative because that's when bone mineral density tends to decline as well. But things like kefir are substitutes that we could take. There's a lot of substitute type of products now that you can still get the calcium, because that's what that's what Dairy Council always pushes, right? Is this calcium, even though a big part of dairy is also the protein, the whey protein and the casein protein. But calcium is a big part of that food group, right? So trying to get that in when you're lactose intolerant is tough, but there are substitutes out there now. And if you look at other complete proteins and other sources of calcium like broccoli, kale, asparagus are great sources of calcium as well. Okay. Other things on here, big debate, alternatives, I should say. for carbohydrates. So what I'm talking about here is like Diet Coke. I don't want to drink a Coke that has sucrose in it because I'll get fat, but I'll drink a Coke that has aspartame or aspartame, depending on how you want to pronounce it, in it. And there's been a big debate, right, about aspartame and aspartame and taken out of products. You have these, in other words, you have these sweeteners of some sort, stevia, right? All these artificial sweeteners. And what I would say to that, most of these, all of these have been checked out, but checked out, I mean by that is research has been done on to make sure they're safe. Okay, the government says they're cool, you can drink them, and you can. But here's the problem with a lot of these, is that when they're conceived or when they're found, okay, like stevia, the idea is that they're not consumed in the amounts that people consume them. So if you drink a 6-pack of Diet Coke and a whole bunch of candy bars and foodstuffs that have these type of compounds in them, I don't think we really have a good grasp on what these large amounts of these sweeteners do. Now, I'm not saying they're good or bad. I'm just saying be careful with them because we're not sure, I think, in the quantities people are consuming them if they're healthy or not. The other problem that people have raised with alternative solutions to sugar, simple sugars, and still have that sweet feeling when we're eating, or sweet taste when we're eating, is do we really eat less when we do that? Do we really have less calories? Because if we're not registering glucose, if our body doesn't see glucose and have an insulin response, it may say, look, I'm still hungry for something sweet. And so you drink your Diet Coke and you think, awesome, I had no calories from my Coke, but you're still craving something sweet. So you go later and buy 2 candy bars and eat them. You might have ate more, right, candy bar sugar than if you would just drank that Coke in the first place and not had these artificial sweeteners. And the research is, there's a pretty good research that's starting to come out that's saying, look, maybe these alternatives are not as good as we think. This is my personal thing. Okay, this is not in your book. This is Dr. Miller's opinion. I would rather drink something or eat something that I know what it is. I know what sucrose does. Is it good? No, not in high amounts. But I know exactly how it's going to be metabolized. Okay, I don't have any question about how it's metabolized. My biggest thing is I have to be careful with how much I consume. Where these, right? So our society in its constant quest for being able to get something for nothing, right? I want to eat 50 candy bars, but I don't want to get fat. Well, you know what? There's no shortcuts. There is no shortcuts. If you want to be healthy, you eat healthy. You eat in moderation, like we talked about in the last chapter, right? Moderation, okay? And you exercise. That's how you're going to be healthy. Okay, supplements, even, we'll talk about those later. They can do something for short term, but they're not a long-term solution. The best solution is to make dietary changes that'll last. Okay, so when we talk about, when you guys will analyze your own diet, maybe you find that you're eating a lot of disaccharides. Okay, well, guess what? You should be eating more polysaccharides. Doesn't mean you have to throw carbohydrates out, but you need to eat more complex carbohydrates, aka polysaccharides. Okay, so that's a basic understanding of carbohydrate and carbohydrate metabolism. All right. In our small intestine, again, we're going to break things down, these being like polysaccharides, even disaccharides, into monosaccharides in order to absorb them right into the bloodstream, right off the small intestine. Remember we talked about villi and the microvilli, right? We're going to absorb these guys right in. Okay. So that's why I mentioned before, if we have a ton of sucrose and we absorb it very, very quickly, we're going to have a huge insulin response, right? Because our body's going to say, tons of glucose, big insulin response, suck glucose out because our body overreacts, right? And then we feel, I feel like terrible, right? And then it takes a while to restore glucose levels, okay? Insulin has some, what we call counter-regulatory hormones. Your book really talks about one specifically, and that it talks about glucagon. Glucagon also comes from the pancreas, and it'll help push up blood glucose. So in other words, from the liver in particular, it's going to tell the liver, hey, release more glucose into the bloodstream because maybe we had this huge insulin response, or maybe we're exercising, right, and our glucose levels are low. Okay, glucagon is going to help increase the amount of glucose available. I'll just say this, it won't be on a test, but we have other major players in that group like norepinephrine and epinephrine, aka adrenaline and noradrenaline, that also push up our amount of glucose availability and liberate glycogen into glucose. Glycogen is just a bunch of, it's kind of cool looking actually if you look under a microscope, but or glycogen is just a bunch of glucose molecules all strung together. It's almost like a little fern blowing, and it's really pretty, actually. And what we do is kind of just pluck glucose off the glycogen and then burn it. Okay. All right. If you remember, carbohydrates carry a 4 calorie per gram cost. Again, the biggest problem with these guys, though, is the overconsumption of our refined sugars or our simple sugars. That's going to cause the biggest problem in terms of our health, because we have to regulate blood glucose levels, which in turn, an overabundance of glucose, fructose, really, watch that video, I think you'll enjoy it. Overabundance of fructose especially gets turned into fat. Fat interferes with the insulin receptor. Insulin receptor doesn't work anymore. Now we're type 2 diabetic, and we're obese. Now we have cardiovascular disease as a result of this high amount of fat and cholesterol. You can see this nasty spiral because we have an overconsumption of disaccharides in particular. Okay. The other thing I just wanted to mention was the glycemic index. And there's a lot of debate about the glycemic index. What the glycemic index is based off it's based off of white bread. Okay, so white bread is kind of the reference. So we say, is something more toward the side of a simple sugar or less than white bread? So like a soda would have a high glycemic index. In other words, it's not going to last very long. Low glycemic foods might be some of our like vegetables, right, that have some food or fruits, or more important, I should say, even best example is like whole grains, right? They're going to be more polysaccharide dominant, and so we don't have this big glycemic response. In other words, we don't have this big insulin response, and so those foods that are low on the glycemic index should be healthier, and they shouldn't be absorbed as quickly, therefore overloading the system and having those sugars turn into fat. Okay, glycemic load, you may hear of that. That's related to the actual amount of food. So instead of just saying my pear has a glycemic index of 40, the white bread's 100, by the way. So my pear has a glycemic of 40. Well, let's compare it to actual how much pear there is. Excuse me. Its glycemic index, very emotional. So my pear weighs X amount of grams per amount of carbohydrate in it, right? So that's a better way of comparing foods. Otherwise, we just say, I have a pear. It's like, well, how big is the pear? I mean, the bigger the pear, or that affects potentially how much the glycemic load is, or like a meal, right? It's a little bit more of a more descriptive way of having an idea of how much a meal will do in terms of an insulin response. Okay, so I just want you to be aware of those terms. I think the glycemic index is a great place to start, at least. A lot of people are debate around it. They say a glycemic load is better. Bottom line is, look at your book. I think it at least give you an idea, though, of if something is really high in the glycemic index, then it's something you probably want to limit. Okay, talk about the stoplight method, right? That's probably going to be more of a red food. Where something is low in the glycemic index, then it's probably something that's more of a green food. Okay, so that's carbohydrates in a nutshell. There's more to talk about, but I'm just going to leave it at that. Again, don't forget the general recommendations for like fiber, and then how much, how much calories from a day from actual sugars. Again, I would say that's quite a bit. 500 calories per day. That's a lot of sugar. Okay, it should be even lower than that. All right, we got to limit the amount of extra sugar that we have in our diets. Good luck doing that, because you'll do a little challenge later in the class, a supermarket challenge. One of the challenges is find some bread that doesn't have high fructose corn syrup in it. Okay, you're going to see that high fructose corn syrup. And what is high fructose corn syrup? High fructose corn syrup is just as it sounds. There's more fructose in it. Okay, instead of being 50-50 like with sucrose, there's more fructose, which makes it taste sweet, makes it taste really good. The problem is that fructose is not a molecule that insulin even recognizes. So there's, again, watch that video. If some things to really think about related to fructose is overconsumption of fructose is a very, 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 very dangerous thing to have happen, and we're doing it in record amounts here in the United States and in the Western world in general. Okay, so I'll leave that talk to kind of go over the biochemistry. I won't rehash it here, and then you'll hear it again, but at least you've had just some basic carbohydrate information. Okay, that's it for now. Make sure you do all your homework, aka the assignment for the week, and get that quiz done. I hope you enjoy that video on high fructose corn syrup. At the worst, even if you don't believe what's going on, yeah, it's a bunch of crap. At least it'll give you some biochemistry about how carbohydrates are metabolized. Okay, and I think that's a really valuable thing to understand as the world basically is turning on carbohydrates, which again, it's a bad thing to do. Okay, if you have any questions, shoot me an emails.